GCD. This is an English way of writing down a term which you may be familiar with already from class. GCD stands for greatest common divisor. What that means is it's the biggest number that divides both of them. So this is it's exactly what it says, the greatest common divisor. You may have heard of other ways of saying the same thing. And since we are also using this class to introduce English terminology, English words, we can also say it is greatest common factor. In that case, you may see it written as GCF. So when you're reading mathematics, if you see GCD or if you see GCF, they are the same thing. You may also see, when people do a lot of number theory calculations, it takes a long time to write GCD all the time. So sometimes people also just write this as 1001,728. But however you write it, all of them mean the same thing. What all of them mean is, it's a question. Find the biggest number, biggest whole number, biggest integer that divides both of them. I'm using that terminology. I'll also put another terminology underneath it. That divides both. I'll just write both of them. Both. We use this way of saying that divides both. And you will even see me introduce a symbol for divides at some point in this class also. Another thing that people sometimes say is it's the biggest integer that is a factor of both. Again, both of these two mean the same thing. But the way that we usually discuss this in America is with the word divides. And I want to do a few sentences with the divides, because that's what I'm going to say throughout this course. For example, I can say that 9 divides 27. This is true. I can also say that 4 divides 400. And as you can see, this takes a lot of space to write. So we have a different way of writing this, and you'll see this throughout the course, that saves writing. We write this usually as 9 vertical bar 27. This looks sort of like a fraction symbol, just vertical, and that means the same thing. But you'll see me say 9 divides 27, and when I say the word divides, I will just draw a vertical line. I can also say this is 4 divides 400. Well then, we do this because it makes it easy to write down when something does not divide. For example, 4 does not divide 29. Okay, that's obvious. 4 is even, 29 is odd. And the way you write this in this notation is 4 does not, vertical bar with a strike through, 29. And you will see this notation internationally. Everyone uses this way of writing. Okay. Then what is the greatest common divisor looking for? You can see why it's called divisor with the D. The greatest common divisor wants the biggest integer that divides both of them. There are many ways to calculate the greatest common divisor. Since this is an introduction, this lesson's an introduction, I'm going to use this lesson to show the basic way. We'll do another way next, in the next lesson. the two numbers I had were, well, I wanted GCD of 1001 and 728. If I know that I want the greatest common divisor, one way you can think of doing this is if you could prime factorize the two numbers and look for common factors. For this lesson, that's why I chose two very interesting numbers to play with. Prime factorize. To prime factorize a number, I need to write 1001 as something times something times something times something. I want to break this apart into its little pieces. Well, of course, I can say 1001 is 1 times 1001. But this doesn't help you at all. This is just useless. It's still the same as before. So this we don't use. And by the way, that's why 1 is not a prime number. Okay? Many people sometimes ask, why is 1 not a prime number? Well, the reason why 1 is not a prime is because it is not useful for prime factorization. Factorization. If you use a 1, your number is still as big as it was before. Well, if I want to take 1001, there are some division tricks that we can use to test what are the factors. 1001. If I want to break it into primes, the first question is it divisible by 2? And you'll already see me writing this vertical bar. Well, that's obvious. It's not, because the end of it is an odd number. So I'm just going to indicate that causes the answer to be no. Does 3 divide 1001? On this one, I'm going to very quickly remind or very quickly show how you test the 3. It's the same thing we just did with the 101. On this, how you test the 3 is you just say that 1001, well, that is 1 plus 0 times 10. 10, I will write as just 3, I'll write as 9 plus 1 plus 0 times, the next one is 10 squared, 9 plus 1 squared, and the last one is 1 times 1000, which is 9 plus 1 cubed. And because of what we did last time, you can immediately see that if I want to know what this is, 1001, what it is mod 3, all I have to do is I keep the 1 plus the 9 is a multiple of 3. So I keep another, this is 0 times 1, so it's 0. Then I keep a 0. And the last one, the 9, is a multiple of 3, so it's 1 times 1 cubed. And so I just add up the digits. That's the trick that you're used to learning. Add up the digits mod 3. And since the sum of the digits mod 3 is 2, then this is not a multiple of 3. And so that means that the answer here is also no. Okay, the next one, does 5 divide 1001? That's also clear. 5 does not divide 1001. It's a no, because the last digit is all you have to check. With 5, no. So let's go on to 7. If I want to check 7, I'm just going to check 7 like this. And 7 times 1 is 7, with 3 as a remainder, 30. 4, it gives me 28, with 2 as a remainder, 21. 3, excellent. So now 1001 has a 7 inside it. 143, how do I break 143 apart? When you do prime factorization, you always try again your 7. That's not going to help now. 14, 0, 3, and that will have not a very good remainder. I will put a 0, 0, 3, and that's my remainder. No. So then I need to check the next thing. If I want to check the next thing, 143 divide, I have to check testing division by 11. For 143, we can just review. We can review the method we used for division by 101, because this is just 3 times 1 plus 4 times 10, which is 11 minus 1 now, plus 1 times 11 minus 1 squared. That's how we pull this together, which, as we did before, is when we do mod 11, all of these pieces have 11s in them. So it becomes 3 minus 4 plus 1. Excellent. When I put these together, that is 0 mod 11. What we have just seen is that the 11 divisibility trick, again, you may have seen it before, but now you know 11 divisibility trick is you put a plus sign on the last digit, then you put a minus sign on the second last digit, and a plus sign on the next last digit, and go on. Well, since it's divisible by 11, I should actually divide it by 11. 1, 4, 3, divide 11. Let's put 1, get 11. 33, take a 3, 33. Perfect. So we have concluded that 1001 is a beautiful number. 1001 is equal to 7 times 11 times 13. I wanted to share that because there are some nice coincidences in numbers. And the more of them that you know, the better. And 1001 is so special. It is 3 prime numbers all put together, but 3 consecutive prime numbers, the ones right next to each other, as close as you can. That was my first one. What was the other number? The other number was 728. You can factorize this the normal way by trying to find 2s, 3s, 4s. But I want to say there's another reason I put this number here. There's another way to factorize 728. 728 may make you think of another number which is very famous or very, very common, which is very close to it. That other number is called 729. It's very close to 729. Why is 729 so special? Well, as you do a lot of this number theory or calculations, you may have come across 729 before. You see, if I look at powers of 3, 3 to the 1 is 3. 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81. I'm just sharing that it's very healthy and nice to know a lot of these, to see a lot of these powers, not because you need to memorize them, but because the more times you see them, the more coincidences you may notice. Because 3 to the 6th is 729. Now, what that really means is that this is 3 to the 6th minus 1. I want to factor. If I want to factor a number, and I already have it written as a difference of powers, there's a very nice algebra trick that you can use, which is that if you have 2 square numbers subtracted, then it factorizes. What do I mean by 2 square numbers? 3 to the 6th is 3 cubed squared. Here's my 3 cubed. So it's 27 squared minus 1, which factorizes as a product 27 minus 1 times 27 plus 1. If you ever see a factorization problem on a math competition, make sure you look for these coincidences, because sometimes they're very helpful. This now, I already factored. It's already into 2 parts. And if you are not familiar with this algebra trick, just multiply. 27 times 27 gives you the 27 squared. But then the 27 times plus 1 cancels the 27 times minus 1. And you just have the minus 1 left. Oh, but this I can break apart. This is 26 times 28. Those are easy to factor now. If I already have 26, 28, maybe you already see, maybe I'll put on the left side here because it's so easy. 26 is 2 times 13. And 28 is another 4 times 7, or it's 2 times 2 times 7. As you can see, I made them all primes because now to finish, what's the greatest common divisor? Well, this has a 7 inside it, and there's no 7 anywhere else. Oh, so the common divisor, I can see that I will take the 7, and I will also take the 13, but I cannot take any of the 11. There's no 11 here. When you have prime factorization, it's like you're building things out of different kinds of blocks, and you find the common blocks on both. So the answer to this GCD between 1001 and 728 is just 7 times 13. And that one we could multiply together. I'll tell you that one is 91. That's a number we see often. But in summary, how was this done? We did this one with, I would say, the basic method, where you prime factorize the numbers. But I wanted to use this as a chance to also review the divisibility tricks and also to share unusual number 1001 and unusual way to factorize a number which may look like another one using a trick.